Hello, everyone. Today I will present on missing data analysis. This presentation is available in my GitHub repository, or you can also get the copy of this presentation in my Analytics Hub. So with this presentation, I will cover on the missing data analysis. That means different techniques of missing data analysis. Technically is logical as well as statistical imputation. So we'll see different types of imputations. That means forward imputation, backward imputation, and also using a mean imputation as well as with statistical imputations. That means using multiple imputation techniques. So this is some of the comments I put in my GitHub address, so you can see different options for inputting data, and also more importantly, it's important to explore data. What is the missing pattern? How many columns are missed, or how many variables are missed? How many are completed? So it is really important to understand the data before making an imputation. Then once we identified the imputation, then the next step is doing a proper missing data analysis techniques. So we'll go step by step with an example. So here's my code. So just I need mice for multiple imputation and basic data imputation. Data manipulation packages. So this is just my data preparation stage. So I'll just start one. So now I will do in my previous presentation, I will do unique identifier. That means project identifier need to identify text. So this is code. That means we sub the first name. That means first 4 letters of the first name, and we have a vertical slash and the 4 letters of the last name and with date of birth. So this is just unique identifier, and then we can do a missing analysis. So this missing pattern analysis, we will see how our missing, like for example, these columns are missed, but we have columns, for example, that have a missing value. For example, birth date has some missing over here, some zeros, as we observe here, are the missing values per each variable. This is very important to grossly look how is the data looks like, the missing pattern, and then we can also do the missing values across all columns. For example, summary columns is NA, so we'll filter out any NS in each variable. So for birth date, we have 40 date of days. We have 40 missing values. For drivers, we have 4 missing values. For passport, we have 12 missing values. So these are all missing values across different variables. And also we can also see how many individuals are missed. So totally a total of 220 individuals have a missing value. So it's very important to understand how many missings are important. Then we can also see, for example, in these individuals with at least 1 missing value. So this one also gives, I hope, the same number. So an individuals have at least 1 missing value. There are 40 individuals. That means actually a unique identifier, because one individual have a missing value for marital status, for area, for example, for diabetes, or for hypertension, for different demographic variables. For in this in data, 40 individuals have a missing value. So it is important, because before doing any missing data analysis, the first and the most important step is its missing value and the missing pattern. Once we have that, then sort the record, and also want to see how the missing value looks like. So as we observed here, so for example, this individual actually filtered 3 variables. That means race, income, and passport. So for race, for example, we have NS. These are missing values. For income, we have also, for example, these are top 10 observations. That means it is top 12, sorry. So have all these missing values with NA. The other is we can input, for example, if we input something with a predefined value. For example, I want to input with unknown rather than just you can use unknown or anything. For example, for hypertension, you can use hypertension. For diabetes, you can say diabetes, or for cancer, you can say yes for cancer. So you can use, instead of unknown, you can say yes, you can say no. Anyways, depending on your variable type, you can input with some known thing. So now for passport, all those NA values, as you see here, are now changed into unknown. So this is just one of a basic technique. The other thing I want to show you is also, I'll just zoom this one and I'll show you the missing pattern. So this is the red line, shows how many missing values per different variables as well. So these reds are showing, for example, variable names at the top because I have a lot of variables, so it is not really readable. But if you expand a little bit more, or if you slice down number of variables, still you can have an opportunity to look the number of missing values as well. So now we'll go to just next step, just preparing our data. For example, we have NA values and for race and income. Of the thing I want to apply in here is forward imputation. Forward imputation is important. For example, if there is a basic measurement, if we know, for example, an individual is white at the beginning, then we can that one into the consecutive numbers, or this is applied for that are not changed over time. For example, a person diagnosed with chronic hypertension or chronic diabetes or cancer, because these diseases are usually not curable. So if we know at any stage, for example, if we have a repeated measurement, then if we know at any step, then we can input that into forward imputation. That means if an individual is white, or individual have hypertension, diabetes, or diabetes in 1, and if there is missing in survey 2 or survey 4 or survey 5, then we can input forward. So this is really important in our data application. So this is one of the forward imputation technique. So we technically use direction down for forward imputations. That means from the top to down. So we have now created a forward variable, race forward, which is equal to race. Then we inputted by to down. That means a forward imputation. Now we have created this one, and then we'll see some observations. So when we observe here, for example, this individual was white, so we input, then it becomes white. This individual have also the same race, input them for example, this individual white, then it was missing, then it is white, because this individual has many observations. We have 4 observations out of 4, 2 are missing, then we can input with the first one to the consecutive values. And this individual has observations. That means there is a repeated measurement on the same individuals on 4 times. So there was yes at the beginning of the survey, but it was missing in the last 2 surveys, and then there is no missing. So we can input that one using a forward imputation technique. We can also check the tail as well. So if we get another type, because at the moment it is more of got the one. So this one gives more types of race. It's still white because data has race. Most of the participants are white. That's why it shows white anyways. But it's good. It shows how our imputation works. The other is backward imputation. Backward imputation is important. For example, for race, we can backward imputation as well, because we know the individual is white or black or Asian at any stage, then we can input backward or forward. Or sometimes, for example, for violence, if we know a person is violated at any stage in his life, we can input that into backward. That means, for example, an individual for violence might be missing at survey 1, that means at measurement 1. It may be missing at measurement 2, or it may be missing at measurement 3. So in this case, if an individual has a missing value at any stage, then we can forward as well as backward. So this we can also use rest. So the direction is up, means usually backward imputation is from last observation to the top. So have direction up. So that's why I use this direction up to do backward imputation. So we can click now this one. We'll see, for example, this one. For example, for this individual, the beginning it's missing, so still will appear as missing because there is no observation before this number 4. But there is an observation before number 2, means this one. So we are inputted by 3. That means technically input from bottom to up. So for this individual, similarly, on number 4, it is missing. So because there is no observation after number 4, so still remains missing, but the others are inputted. For example, number 2 was missing, but it is inputted by number 3 here. That means this value is coming from this one. So this is a backward imputation technique. It's really interesting to see these differences. The other is mean imputation for continuous variables. This is, for example, the previous example we observed is for categorical variables, but for continuous variables, like for example, height, weight, body mass index, hypertension, in terms of systolic, diastolic measurements, we can use a mean imputation, which is usually applicable. There are 2 types of mean imputation. One is a global mean. That means we can take the whole observation mean and input all missing values with that global mean. The other one is, for example, if there is repeated measurement on the individuals. For example, if an individual is measured at survey 1, survey 2, or hospital visit, for example, if they measured at hospital visit 1, hospital visit 2, hospital visit 3, hospital visit 5, something like that. And if there is missing in some visits, then we can input that. So the one is using a global mean imputation. Option 2 is calculating the same individual mean. That means we calculate, for example, for this one individual, there are surveys. From 5 surveys, we can calculate the mean imputation within the same individual, and then we input those missing values for the same individuals. So if an individual have, for example, 20, 30, 40, we take the average of 20, 30, 40 for the same individual and input the missing value by that average value. So this is one of the good, for example, for repeated measure values rather than applying the global mean. It is important to use individual specific mean value if it is repeated measurement. That means if the individual has repeated data collection 3 or more times or 2 or more times anyways. So let's go with the global mean. So the global mean imputation is, for example, we calculate mean here, and then we technically, if any missing value in income, we are saying use a global mean income. If it's not missing, we can use just income. So this is just using if else statement. That means if else verb, using if else verb, we are ordering R to an imputation for income based on the global income values. So this is the value. So for this one, as we observe, so we say global means they will have the same mean across different means. So these missing values are inputted by 96, 123. That means the mean value. So as you observe, it is also similar. So this is one of the technique anyways for mean data imputation. The other is calculating a specific mean as previously noted, especially if there is a repeated measurement. As we see here, an individuals have the repeated measurement, for example, up to 4 times. This scenario, repeated measurement is really important rather than global mean. So we calculate a mean value by, that means we say group by ID and summarize mean income ID is equal to mean by group. So this is very important step zone. So we calculated the mean per each individual. Then the next step is use participant level mean to input the missing value. So we are using ifelse, and so we say if there is any missing value in income, then we are ordering to use a mean income ID. That means the one we created on the above per each individual. That means ID text is individual, so we created by individual and we calculated the mean values by each individual. So we'll see the observations as we see here. For example, this individual has 1980,002. This individual has, that is the same individual, but individual have 177,823 mean value. So we inputted all these values for the same individual, and this individual has 114,272 missing mean values, and we input them with that missing value. So this is one of the techniques to input missing value for mean or continuous data. Technically, this as an income and an example. The other option is multiple imputation. So multiple imputation, you can use Hmisc package R. And so example, for this one, I want to all these different variables. We have zip, healthcare coverage, income, and FIPS, all these variables. I want to do an imputation. So let's select this one. Then I say this is my data frame, the new data frame. I say Hmisc, which is doing the imputation using PMM. So say PMM and 1 times and then technique. So let's move there. The imputation is completed, so we can see our result looks like. Maybe I can open the data and I'll show you how the inputted end. And this is the inputted values. So where is input? This one. From here, oh, sorry. So this is actually the one which is joined. So this stage we created the inputted the function, and then we retrieve the completed data set. That means we in the input values. So now we will join all those inputted values and example, healthcare coverage and income, their missing values has inputted. So let's see which is the data frame we used. That means this one. So FIPS, for example, we have this, as you see here, there is missing values, but they have inputted with multiple imputation technique here. For zip, it is also has missing value here, and those missing values have been inputted. And for healthcare coverage, there was missing values here, as you see here, and those missing values has inputted there. For income, similarly, there was inputted missing values here, and they are inputted using package. So this is one of the good technique for multiple imputation, but one of the things I want to emphasize here is multiple imputation. We should also do modeling to identify what is the best predictor, the variable, for example, for healthcare coverage or for income and other, what are the best predictor to get the best outcome. So you can have a look if you are interested. This is just to check the final one and the inputted and non-inputted one, actually just the same as we did previously. So this one is, for example, for race, this is a summary actually. For race, using a forward imputation, we have inputted here. For backward imputation, we are also doing the same Sometimes if it is on number 4, sometimes it may be as non-missing. For example, in this case, because it is number 4, so it's still missing. This one is also an individual have on 4. So using backward imputation, it still remains missing. For income, for example, we have inputted using a global mean, or you have also inputted with participant mean. So this is just one of the quick overview of the imputation technique we observed. So this is all about this presentation. As I previously noted, this presentation is also available my function. You can have a look in my GitHub repository with more details about different types of techniques of imputation and their functions and their importance. But one of the things I want to emphasize is in day-to-day data analysis, missing data imputation is important. So there are steps. That means we need to identify what is the missing value. And then once we identify it, we need to choose which missing imputation is more appropriate, because there are different types of missing data imputation. It may be forward, maybe backward, maybe mean. For mean also there are global mean or individual specific mean, or it may be multiple imputation. I hope you enjoyed this presentation. Thank you.